Okay, class, we're about to start section 5.5, more properties of logarithms. Our goal in this section is to be able to solve equations that contain more than one logarithm. We will only look at equations in which all the logarithms have the same base. In order to work with these equations, we will need to be able to collect logarithms, combine all logarithms into one logarithm term with a coefficient of 1. The following properties help us do this. So we could label these as 1, 2, and 3. Number 1 is the power property of logs, which we have been doing in section 5, 3, and 4, which we see here. We have log our base, this value to the p power. We bring p out front. Now the product property of logarithms, we have log of the base and we have x times y. We could separate that. Our base will still be b, but we'll separate the x and the y and we will add them together. Now with the quotient property, we would do exactly the same thing here, except for we would have subtraction. So we have log b, the numerator goes first, minus log base b and the denominator goes second. So now, let's go down here to example 1. It says collect logarithms in each expression. Write your result as a single logarithm with a coefficient of 1. So now we have 3 times log of x plus log of 2x. So first of all, let's move this 3 and make it an exponent. So we will have log of x to the third power plus log of 2x. Now, since these two are added together and have the same base, we can make this into one logarithm with multiplication. So we have log x to the third times 2x, and we can combine that. So we have log 2 times x to the fourth, and that will be our final answer. Now we go here. First of all, we have this 3 out front. We will make that an exponent. We add this 2 out front. We will make that an exponent. So we have log base 5 of 2x to the third power minus log base 5 of 4x to the second power. Now, if you notice here, we have subtraction. They have the same base. So we have log with that same base, but we will have to make this into an exponent. Now, we have to be careful here. As a matter of fact, let me do this first before we do this as a fraction. Let's take this whole parenthesis to the third power. 2 to the third is 8x. X will become x to the third, because that's x to the first to the third, minus log of 5. And 4 to the second is 16, and x to the first to the second will give us x to the second power. Now we will put this in a quotient form. So it'll be log base 5. And we will have 8x to the third in our numerator and 16x squared in our denominator. Now we could simplify that. It'll be log base 5. We know that 8 and 16, we know that'll be 1/2. And x cubed divided by x squared would be x. So it'll be x over 2. And this is our final answer. Now we look here at C, which is a little longer. But we still start off by taking these numbers on the outside and making them exponents. So we have log base b of t to the second power plus log base b of 6t to the third power minus log base b of t to the 8th power. Now we can combine all of these. We know first we would start off with multiplication and end with division. So we will have log base b, and in parentheses we have t squared times 6t to the third, and that is all over t to the 8th, as all of them have the same base. So we can combine them like this. Now, we will have log base b, t squared times 6t to the third will give us 6t to the 5th, all over t to the 8th. Now we can simplify this. This will give us log base b, and we will have 6 all over t to the third power. And that will be our final answer. Now we go here to D. Now again, we take these numbers on the outside and make them the exponents. Let me draw a little line here to separate this. So we will have log base b of x to the second to the third plus log base b of 7x minus log base b of 4x to the second power. So now we will have, now remember that is a 3. So this would be log base b of x to the sixth power plus log base b of 7x minus log base b of 4 to the second, which is 16, and x to the first to the second, which would be x to the second. Now, again, now we can combine them. We will have log base b, in our numerator we have x to the sixth times 7x, all over our denominator, which would be 16x squared. So we have log base b. This will give us 7x to the 7, all over 16x to the second. So this will give us log base b, and in parentheses we have 7x to the fifth, all over 16. And that is the final answer. Now we come down to the next page. It says how to solve an equation with more than one logarithm. First, we collect the logarithms, isolate the remaining logarithm by itself on one side of the equation, rewrite the problem in exponential form, and solve for x. Note, we will only look at equations in which all the logarithms have the same base. So now, solve each equation, give 3 decimal places. So, we would have, first of all, we would take these numbers on the outside and make them exponents, like we did in the other problems. So we would have, this would end up being log base of 4, x to the 9th, minus log base of 4, and this will give us x to the 6th. It's equal to 2. Now we can combine these logarithms. We have log base 4. This would give us x to the 9th over x to the 6th. And that's still equal to 2. So this will give us log base 4. And this will end up being x to the 3rd is equal to 2. So now we will write this as an exponent. So we have 4 to the 2nd power is equal to x to the 3rd power. Now, we need to get rid of this 3rd power off of x, so we could take both sides to the reciprocal of that power, which would be 1/3. So this will end up giving us 4 to the 2/3 power is equal to x. Now, when you put this in your calculator, you will end up with x, and it's going to be approximately 2.52. Now this is your final answer. Now, we scroll down here to B. Now again, we put those powers, we make them the numbers on the outside exponents. So we will have log 2x to the 3rd power is equal to 4 minus log x to the 4th. Now, we will add log x to the 4th to both sides, because remember we want to get all of our logs on one side. So we will have log. Now what we could do here is we could take 2 to the 3rd power, which is 8, x to the 1st to the 3rd, which is x to the 3rd, plus log x to the 4th, and that equals 4. Now we can combine these like terms here. We can combine the logs. So we have log, and since this is addition with the same base, we will multiply. Log 8x to the 3rd times x to the 4th is equal to 4. So we have the log it'll be 8x to the 7 is equal to 4. Now, we need to write this as an exponent. Remember, this base is 10. So really, this leads us to 10 to the 4th power is equal to 8x to the 7. Now, we need to divide each side by 8. Now, of course, we know 10 to the 4th power is 10,000 over 8, and that's x to the 7th power. Now, 10,000 divided by 8 is 1,250, and that equals x to the 7. And we would take the reciprocal exponent to get x by itself. So we would get an approximation here of x, and it would end up being 2.77. And that is the final answer. Now we go to the next page where we have the change of base formula. It allows us to convert logarithms from one base to another. We usually do this to convert a logarithm to base 10. It should be base 10, not base then. Base 10, since we can evaluate base 10 common logarithms on the calculator. The general log form, we have log base b of x is equal to log a of x and log a of b. Now this a is actually base 10, so this is really log base 10 of x and log base 10 of b. Now base 10 common log formula, and we show this here. It'll be log x over log b. Okay, so now, because remember, we don't have to write the 10 for the base. So log 6 of 55, we could rewrite this as log base 10 of 55 all over log base 10 of 6. Now if you notice, the number that's further away goes on top, and the base and the log goes on the bottom. And that will give us an approximate answer of 2.2365. Now we go here, we have log base of 25 of 8, so that will give us log of 8 divided by log of 25, and that will give us an approximate answer of 0.6460. Now below here we have our TI-84 calculator instructions. You can read those at your leisure, and if you have any questions, you could first try this website, and then if you still have questions, please come to class and I will answer any questions you may have. Now we scroll down here to example 4. It says find the solution of the following equation. Show a labeled sketch of the graph for work. Give 3 decimal places. Okay, now just like we did in section 5.4, we need to take this value here and set this in y of 1 in our calculator, and this would be y2, and we would graph both of these here. Now we could go through, this would give us log x plus 6 all over log 3 plus 3 times the log of x plus 8 over log of 4. Now again, we got these values by using the change of base formula. This is log of x plus 6 over log 3 plus 3 times the log of x plus 8 all over log 4. Now, you put this in your calculator and you will wind up with both of these graphs here. This graph here represents 3 to the x plus 2. This graph here represents the log 3 of x plus 6 plus 3 log 4 of x plus 8. Now, you get their intersection points. We have 2 intersection points here. One is at negative 5.211, comma 2.003, and the other is 1.403 at 6.672. So our final answer will give us x is equal to a negative 5.211 or 1.403. And that would be our final answers. And we're done.